Hello everybody and welcome back to another SFML tutorial. In this tutorial we're going to talk about 2D animation. So first of all, what is 2D animation? Well, 2D animation is basically switching between certain images in a certain amount of time. So if you take a look at the sprite sheet of Tux, then you will see that each line represents an animation. So the first line is this idle animation, and this last line is this dying animation, then you have jumping and kicking, whatever. So what we can do is we can create a class that basically cycles between each segment of the animation. So let's do that. The first thing that we're going to need is a class called animation. So let's create that. Add class, okay, C++ class, and it's called animation. And then animation is going to need a few private variables. The first thing that it's going to need is an SFVector2U. And what this SFVector2U is going to be the image count. So if you remember from last episode, we divided the size by the amount of images in each row and in each column in order to calculate the size of a single tux. But for animation, we're going to have to store the value. We're going to have to store the amount of images that we have in each row and the amount of rows that we have. So we're going to store that in this variable. We're going to have to include SFML graphics. The next thing that we're going to need is the current image. This is also going to be an SFVector2U. It's going to be called current image. The reason that these are vector2u's and not vector2i's for integer is because it's never going to be less than 0. If it's less than 0, then you're out of range. Then you're trying to access an image that's not available. Since it's SFML, they're using texture clamp. So basically, if you're trying to access a part of the image that's outside of the image, there are two things that can happen. One thing is you can clamp it. So if you, for instance, trying to access something that's just outside of it, it's just going to clamp it to the end of the image. Or you can have texture repeat, which basically means that whenever you're trying to access something that's outside of the image, it's basically going to copy the image that it has and paste it next to it an infinite amount of time. So it doesn't matter how big your number is, it's always going to be a texture. It's always going to be possible to access a part of a texture. But SFML does not use that. It uses clamp, I think. So we're going to need 3 more variables. The next 2 variables are going to control the speed of the animation, so how quickly you will switch between each image. The first variable that we're going to need is going to be the total times, so the time since we last changed image. So this is going to be just a float called total time, and we're going to need another float called switch time. And what this float is going to contain is the amount of time that it takes before we want to switch to a next image. And finally, the last variable that we're going to need is an SFIndirect. And this indirect is just going to be called UV-rect or texture-rect. This is basically the UV-rect that we want to use in order to display the animation. These are all the variables that we're going to need. And since this needs to be a public variable, I'm just going to put public in front of it, even though we already have a public keyword there. So it's basically already going to be public, but I like to keep my variables separate from the functions. So let's say I want to have a private function, then I will type private here, and then I will type the function. So I'm not going to put it under the same private tag as the variables, because if you're going to have a huge class, it's going to be really annoying to basically have a top segment containing all the public variables and then a bottom segment containing all of the private variables and functions. Okay, so the first thing that we're going to need is we're going to need to modify the constructor. The constructor needs to take an SFTexture pointer called texture. The reason that we're only using the texture and we're not storing it is because we don't care about the texture itself, we only care about the size. And the reason that we're not just passing in the size is because then the constructor call will be quite long, and we don't want that. The next thing that we're going to need is an SFVector2U called image count. And this is basically containing the amount of images that we're going to have. This variable is literally going to be stored in the private variable. And the next thing that we're going to need is a float called switch time. So basically how long we want each part of the animation to take. What we can also do is pass in a total time variable, so how long the animation going to take in total, and then we'll just divide that by the amount of images that we have in each row in order to get the switch time. Okay, so let's now copy this and place it in the constructor. Okay, so now that we have that, it's time to set the image count. Because the variable in the class and the variable we pass into the function are both called the same, we're going to have to use the this keyword. Basically what this is, it's a pointer to this specific class, so this specific instance of the class. This way you can access variables that have the same name. So we're going to type in image count, and we set it equal to image count. As you can see, they're both different colors. The left one has the color of a private variable, or just a variable inside of a class. And the last one has the same color as a variable that we pass into a function. So that's how you know that it's different. Okay, we're going to have to do the same thing for switch time. So this switch time is equal to switch time. And then we're going to have to set a total time. So total time is equal to 0. And we're also going to have to set the current image at x. The current image at x is which image we're currently accessing in the row. And we want that to be 0 since we want to start the animation at 0, obviously. So we're going to do current image at x is equal to 0. The next thing that we're going to do is we're going to calculate the height of each tux and the width of each tux. So in order to do that, we have to access the UV rect that we just created. So UV rect, the width, since we want a width, and we're going to set it equal to texture get size dot x and divided by a float version of image count dot x. The reason that we want to make it a float is because it's an unsigned integer and we're going to get warnings. Warnings are not terrible, but if you get a warning, you should try to fix it. Okay, we're going to have to do the same with the height. So I'm basically going to copy this, change all the x's to y's, and change width to height. Okay. And that's basically it. That's all that this constructor has to do. The next thing that we're going to need to do is we're going to have to create an update function. And this update function is going to take two different variables. So void update, it's going to need an integer called row, basically what row of the animation we want to access. And it's going to need a float called delta time. And what delta time is, it's the time between the previous frame and the current frame, so how long that took. The reason that we want to use delta time, instead of just incrementing a value, is so it will work the same on all different computers. So let's take for instance my computer. My computer is a pretty high-end gaming laptop, so it's going to be able to run this game really good. So my delta time is going to be really low since I'm going to have a lot of frames per second. If we're going to use a counter and let's say you want to switch every 10th of a second, then the number for the counter in order to switch has to be really high because we're going to have a really high FPS. But if we were to use one of my old computers, so one of the old laptops that is still laying around, then the game would run way slower, so it won't be a 10th of a second, but it might be 10 seconds in total before the next switch is going to happen. But if we use delta time, then we can use that for the calculations, and we can basically make it so it runs the same on all computers. Even though it might not be as smooth, the animations will still happen at the same time. Okay, so let's now create the function. Okay. And the update function is gonna need a few things. The first thing that we're gonna need to do is we're gonna have to set the current image.y to row. So current image.y is equal to row. The next thing that we're gonna need to do is we're gonna need to increment total time with delta time. And then we want an if statement, and this if statement is going to contain if total time is bigger or equal than switch time. And what this will contain is total time minus equals switch time. The reason that we want to do minus equals and not is equal to 0 is so we'll have a bit smoother animation, since it's never gonna be exactly equal to the switch time. Even though we have the is equal to, it's never gonna happen. Since we're using floating point values, it's gonna be really difficult to have the same number, especially if we're using a variable like delta time. So it might happen once in a million times. So if we do minus equals, we will still have that little time that was still left in there. So the little time that went over the switch. And even if we have a really low frame rate, then it will just keep on activating this if statement, so nothing bad is going to happen. It's just going to display the animation really slowly because of the frame rate. Okay, so the next thing that we're going to need is current image at x plus plus. And this will basically switch the current image that we have. So if you go back to the tuxes, what will happen is if we'll start at the first tux, then we'll go to the second tux, and then we'll go to the third tux, but then we'll go to the fourth tux, and then we'll go to the fifth tux, but they're not there. There's no fourth and fifth tux. So how do we fix that? Well, we simply use an if statement. And that if statement is going to contain if current image at x is bigger or equal to image count at x. Current image that x is equal to 0. So basically what this will mean is if the current index of the tux is the same or bigger than the amount of tuxes that we have in total, then we'll just simply set it back. This is really important to do because otherwise we're going to have an invisible tux. SFML will not complain about it, but we will not have a visible tux because of the clamping. And the next thing that we're going to need to do is we're going to have to set the left and the top offset of the UV rect. So UV rect dot left is equal to current image at x multiplied by UV rect dot width. Because we already stored the width and the height, we do not have to calculate it again. So this way we don't have to store the texture at all. We only need to use it in order to calculate the width and the height. But after that we already have it and it's not going to change. So we don't have to recalculate it. So we're going to do the same for UV rect dot top. UV rect dot top is equal to current image dot y multiplied by UV rect dot height. And now if you go back to main.cpp and we include animation, then we can create an animation. So the first thing that we're going to need to do is of course create an animation. So animation with the constructor containing the texture. So at player texture and the image count. So in this case we're going to need an SF vector to U containing 3 in the width and 9 in the height. And then at last the switch time. So let's put it at 0.3 seconds. So this will basically mean that the total animation time will be around a second. So this entire part can just go. We don't need it anymore, just like this. It's not necessary anymore. So now we're gonna need a delta time. How do we get a delta time? Well, we're first gonna need a float called delta time. This float is currently still 0.0f, but using an SF clock called clock, we can get the delta time. This clock, if you go in here, has a function called restart. And what the restart returns is an SF time. And what SF time contains is the delta time. But in order to get the delta time, we have to get the function as seconds. So this will return a float. So if we do delta time is equal to clock.restart that as seconds, we get the delta time. And then we can use this in our animation.update function. So animation.update, and then we pass in the row. So let's say we just want the idle animation, then we type in 0, and the delta time is gonna be delta time. And now the only thing left to do is to actually set the UV rect. But because there's a public variable inside of animation, we can simply type in player.setUVRect or set texture rect animation.UVRect. And that should be it. So if you now run the program, you will see that we have a tux that's bouncing up and down. In order to see it better, I'm gonna change the clear color to something different. So we're gonna need an SF color gray. Gray is not a thing. So how do you create one? Just as a constructor? Okay, yeah, just as a constructor. So let's do red, green, blue, alpha. Okay, so it's gonna take a U and 8, so from 0 to 255. So let's do 150, 150, 150. Okay, so this should be a grayish background. So as you can see now, our animation is working. In the next episode, we're gonna make it so we can move the player around and the animation will follow. So if you move left, then the player will move left. If we stand still, the player will do nothing, so it will display this animation. And if you move right, then our player will move right. So thank you for watching, and I'll see you in the next one.